Alright guys, here's the test review video that I'm making just for you at 8:30 at night so you could stay up and study with Mr. Felton as long as you need to. The topics you'll need to know for this include converting grams to atoms, or grams to moles, and moles to atoms, moles to grams. Just remember, what I'm about to draw is your best friend. You can go from mass, which is measured in grams or kilograms, but for this course, up to this point, we've only done grams. You can convert that to moles. Alright, to find out how many moles you have. And then you can go from moles to atoms or molecules. Cool. You cannot, I'm gonna use pink, but pretend it's red. You cannot go this way. You cannot go from atoms to mass. You have to go through the moles. See what I'm saying? Okay. So let's do a problem and see how that will work on the exam. Okay. If I were to say, for example, how many moles are there in 2.2 grams of sodium chloride? So how many moles are there in 2.2 grams of sodium chloride? Well, if I start with 2.2 grams of sodium chloride, and I'm asking you how many moles. Well, according to my triangle, I have to convert this to moles. So we multiply it by its molar mass. Na is 23, Cl is 35.4. Add those together, you'll get 58.4. So in 1 mole, I have 58.4 grams. Right? Grams are going to cancel out. The 2.2 is on top, 5.84 is on bottom. You're going to multiply across, so 2.2 times 1. Right? So you'll have 2.2 divided by 58.4, and that should give you a certain number of moles. I'm going to use my amazing calculator right now. You should end up with 0.038 moles. I'm rounding, but that's roughly how many moles you should get. Cool. So there will be questions like that. So in just that one question, we covered 2 topics. One is converting grams to moles, and the other one is calculating molar mass. So the molar mass of sodium chloride. Cool. Next one. If I were to ask you how many hydrogen atoms there are in 9 grams of water. So I'm asking how many atoms. So question mark, atoms. How many atoms of hydrogen are there in 9 grams of H2O? That's my question. How many atoms are there in 9 grams of H2O? To look at this question, you first need to be able to think, okay, I have a certain number of molecules of water, H2O. I don't just have H, right? But for every 1 molecule of water, I have 2 hydrogen. If I were to say, hey, you have a dozen H2O, so I have 12 H2O. How many hydrogen and how many oxygen do you have? In 12 H2O, I have 24 hydrogen. Do you see I had to multiply this by 2? In oxygen, I have 12. Keep this in mind while we solve this idea, okay? Because I don't have a dozen, you're now dealing with moles, which is that 6.022 times 10 to the 23 that we're looking at. So let's start from the basics. I am going from grams to atoms. Cool. So if I have 9 grams of H2O, I have to calculate how many moles of H2O I have. So in 1 mole, I have how many grams? You should be able to figure out that oxygen is 16 grams per mole, and hydrogen is 1 gram per mole, but I have 2 of them, so this will give me 2. So the total for water is 18 grams for 1 mole. Cancel these out. This is going to give me 9 over 18, which is half of a mole. If I reduce this, or if you use your calculator, you'll get 0.5 moles of H2O. Alright, I'm now going to erase the this area here, so make sure you copy it down or pause the video, copy this down. But I have now figured out that if I have 9 grams of H2O, that means I have 0.5 moles of H2O. Cool. But I need to find out how many atoms of hydrogen are 9 grams of H2O. So I have 0.5 moles of H2O. I now want to convert this to how many molecules do I have. Cool. So I have 0.5 molecules times, 0.5 moles. In 1 mole, how many molecules do I have? This is where you use Avogadro's number. So I have 6.022 times 10 to the 23 molecules. I'm writing molic. You could write out the whole molecules. Moles are going to cancel out. On your calculator, if you multiply 0.5 times Avogadro's number, you should get that you have 3.011 times 10 to the 23 H2O molecules. Okay, so I have this many molecules. I'm going to erase this work now, so if you want to pause the video and make sure you write this out. But this is how many total molecules of H2O I have. I want to rewrite this nicer. So let's start off with that now. This is how many H2O I have. But the question is asking, how many atoms of hydrogen do I have in this many H2O? Remember, like I said, if I told you I had 2 H2O, I only have 2 of them. How many hydrogen do I have? You have to multiply it by 2, because in one H2O, I have 2 hydrogen and 1 oxygen. But I'm telling you I have 2 of them, so you have to multiply hydrogen by 2, this 2, and oxygen by 2. So that gives me 4 hydrogen and 2 oxygen. I don't have 2 though. I have this many. So what do? If I were you, I would pause the video and guess right now, and maybe think about subscribing while you do, if you haven't already. That's a joke. But what I need to do is, I now have 3.011 times 10 to the 23 H2O. So what I need to do is figure out, okay, to get hydrogens, I need to take this number times 2. So for solving for hydrogen, how many hydrogen do I have? It's this times 2, which will give you 6.022 times 10 to the 23 atoms. For oxygen, it's this number times 1, which is 3.011 times 10 to the 23. Here's a practice problem for that one. You can message me if you have my number. Just please don't message me too late. I've got a test tomorrow. Actually, you guys have a test tomorrow, but you know. So an example problem of that, if you want to try it, would be how many atoms are there of hydrogen? So how many hydrogen atoms are there? How many hydrogen atoms are there in, let me think of a good one. In 15 grams of ethane. That's a good one. But first you need to know, what is ethane, Mr. Felton? We forgot. It's one more carbon than methane. I'll tell you that. And there's a hydrocarbon. So figure that out. And try to message me or ask me for the answer. But I think you guys can get it. All right, moving on with different types of problems that will come. I'm actually looking at your test right now. If you guys want to see it, I'll show it to you guys tomorrow morning. Okay, make sure you know types of reactions. Coefficient ratios. Let's do a simple one. I like this example. I would suggest memorizing this example, but if I have H2O goes to H2 plus O2. What type of reaction is this? Well, I'm going from one thing, and it looks like it's being split apart, so that's decomposition. Fine. If I balance it out, you will hopefully end up with 2, 2, and a 1 here, but we don't typically write 1. So the coefficient ratio here is 2, 2, 1. Awesome. So that's a simple one to memorize. What exactly does coefficient ratio mean? You're just writing out the coefficients after you balance it. Be able to solve for oxidation numbers of atoms within a polyatomic ion. So for example, if I said, if I have lithium nitrite, what is the oxidation number for nitrogen? Well, my oxygens are going to give me a total of -4. Lithium is going to give me +1. And the original charge was 0. The original charge was 0. So all of this has to equal 0. So +1 something -4 equals +0. The only thing that nitrogen could be here is +3. So the oxidation number for nitrogen here is +3. I'll give you another one. I like these. It's like a nice puzzle, you know what I'm saying? Okay, let's say I said I have sulfurous acid, and I wanted you to tell me what is the oxidation number for sulfur. So sulfurous acid is H2SO3, as I'm sure you guys all remember. So hydrogens, each one's +1, that's going to give me a total of +2. Oxygen is -6 because I have 3 of them and each one is -2. So what can sulfur be? The total is 0 here. It has to be +4. So 2 + 4 -6 does equal 0. So here S's oxidation number is +4. And again, my suggestion to you throughout this video would be to look at the question, pause it, see if you can solve it yourself, and then go from there. Okay, molarity. Let's do a little bit of molarity. That would be a good tea brand. If I ever came up with tea and it was really concentrated, I could be like, this is molarity. Get yours today. Really concentrated, strong tea, you know what I'm saying? But the equation for molarity is equal to moles per liter. Don't forget this. If I have, what's a good one? If I have 3 grams of, say, CO2, carbon dioxide, dissolved or mixed into 45 milliliters of water. What is the molarity? Try to solve this now. Pause it, if you will. And if you have no clue, you can watch it, but try to solve this on your own. So I have 3 grams of CO2. I know right away I'm going to have to convert that to moles, and that's dissolved into 45 milliliters of H2O. That's in milliliters, so I'm going to have to convert that to liters by dividing by 1,000. And what is the molarity? So let's do it. So right now you should be thinking, okay, what is my molar mass of carbon dioxide? So I got 3 grams of CO2 times carbon is 12 and oxygen is 16 each, so that's a total of 32. Those combined together, it looks like it's going to be 44 grams in 1 mole. Grams are going to cancel. This is going to equal 3 divided by 44, which will equal how many moles? That's going to give me 0.068 moles. So in my molarity equation, molarity is equal to, I've got my moles, so I can put that on top right now, 0.068. Now I just need to convert the 45 milliliters into liters. So divide that by 1,000. That's going to equal 0.045. So I have this many moles divided by 0.045 liters. That's going to give me a molarity of 1.511. Cool. Alright, percent yield. For percent yield, I have to give you, for up to this point, I have to give you the amount that the actual yield that you got, and also the theoretical yield, how much you started with. I have to give you those. Only because you haven't learned yet how to implement that type of calculation inside of a equation. But you will get to that coming up over the next 3 weeks. I can't believe we only have 3 weeks left. I know you guys will miss me, but there's always next year. Maybe. Okay. So let's see here. Let's say in the lab that we just had, I gave you started off with, in your little test tube, a total of 5 grams of sodium chloride. After filtering it out, after doing everything, your whole lab, you were able to get back only 3.5 grams. Good for you. So in here, I told you, hey, I put 5 grams in your test tube, and you ended up with 3.5 grams. That means you lost 1.5 grams somehow. Do you see the difference? There's a difference of 1.5 grams here. You lost it. This happens in science normally. It's normal to happen, but not that much. So in order to find out, hey, how much did we actually get back? How much did we make? How much did we come up with? We use percent yield. How much percent did we actually get of how much we should have gotten? Okay? So in this case, theoretically, you could have gotten back 5 grams because that's how much you started with. Right? But you actually only got 3.5. So this is my theoretical yield. In theory, I should have been able to get 5 grams back, but I actually got 3.5. So this is actual. To get my percent yield, you do actual divided by theoretical times 100. This is the same way you guys would calculate what you got on a test or a quiz. Tomorrow's test is 25 points. Okay? It's 25 points. So theoretically, you could get 25 points. But let's say you only scored 10. Good for you. So you got plus 10. And this is how I write your grades. Every time I write your grade, you're like, oh, sir, what does plus 10 mean? I'm telling you your actual yield on every test. And theoretically, you could have gotten whatever the amount is out of. So let's say you got plus 10 out of 25. You'll do 10 divided by 25 times 100. And what do you know? If you got a 10%, you got a 40%. Good for you. Stay in school. But back to my problem here. I have actual divided by theoretical times 100. So I have 3.5 divided by 5 times 100. Your percent yield here should be, let's see here. 3.5 divided by 5 equals 70%. So if I get a 70% yield, pretend I'm working at a factory called KBS. And I have a 70% success rate. I'm losing 30% every time I'm getting a bunch of supplies, whatever. I'm losing 30%. I'm only getting 70%. Am I doing a good job? I may want to check what's going on here that I'm losing 30%. So for those of you who did the lab and you got a very high percent, I think the highest percent was 98%, which was very good. But if you're getting less than that, it's fine. But if you're in the 40% range, 30% range, there's something obviously wrong. And that's why it's like, hey, what did you do? Oh, I poured some down the sink. And then I'll say, where in the instructions did it say to do that? It didn't. And then you kind of figure out, well, hey, that's why you lost so much. It's the equivalent of I give you a test worth 25 points and you take a page of it out and throw it in the garbage just for fun. And I say, well, what happened to the page? Oh, I don't know. That type of thing. So anyway, that's percent yield. Otherwise, this test is very straightforward. There's only one correct answer per question. So, and if you find a mistake on my exam, for every mistake you find, you'll get a bonus point. Okay? Anyway, best wishes to all of you in studying, if there is such a thing as wishes. And I will be available for any questions you may have.